There are endless stars outside our cosmic system, however, this one is not normal. For some reason, the main close-up picture of a star outside our world shows a red monster that is multiple times bigger than our Sun. Seeing this beast is presently reforming science. It is 2,000 times bigger than the Sun and a logical sensation around 160,000 light-years away. Space experts have found a red giant star that they unexpectedly and understandably named Behemoth. Red giants are swollen stars at the end of their lives. This peculiarity is not that uncommon in the universe, but WG64 is not normal like any other. The first close-up of a star outside our cosmic system uncovers a strange star, as well as one of the most bizarre red giants researchers have ever seen. The star is at home in the huge Magellanic Cloud, a neighboring universe that has been going with our Milky Way for billions of years. The Magellanic Cloud contains around 30 billion stars. Its shape is unpredictable, and it's felt that this system is the result of a previous interaction with the Milky Way or the small Magellanic Cloud, which has changed its original design. Researchers even suspect that the Magellanic Cloud could converge with the Milky Way in a couple of billion years. This consolidation would change the construction of the Milky Way yet again. New star-forming districts would arrive, and the impending consolidation with the Andromeda system could create a captivating dance of three consolidating systems. WG64 will most likely no longer exist by then. The monster star will detonate in a couple of 1,000 to 100,000 years. A hair-raising picture. Thanks to new technology, the Bat star, what makes a giant star a beast? Is it its sheer size, the extremely hot hellfire seething on its surface, or is it the trouble researchers have in concentrating on it? Researchers called red giants behemoths a reference to the Book of Job in the Holy Bible, where behemoths are described as immense, fearsome animals. Behemoths are not only strong but enormous, yet also convey phenomenal heavenly creation. On one hand, the sheer size of this star is intriguing, and on the other, the savagery with which it acts is as well. This star will wreck in the not-so-distant future. During the time when the star has exploded to become a red giant, it will consume everything around it. If WG64 once had planets in its area, they will have been gulped up by the star in a long course of development. So, really epic and scriptural shows are occurring here. It's estimated that in around 4.5 billion years, our Sun will likewise start to expand and gradually assimilate all the planets. Luckily, this moment is reassuringly far in the future. Later on, it's a lot more pleasant to notice such a display from a protected distance than to experience it all alone on the astronomical doorstep. WG64 has been known to analysts for a long while, but as of recently, it was unrealistic to get a close-up of the star and hence find out more about the cycles on its surface. This has now been accomplished thanks to the improvement of a totally new method, GRAV. It's another instrument at the European Southern Observatory's Very Large Telescope Interferometer in Chile. The VLT is one of the most exceptional cosmic instruments on the planet. It combines the force of up to 48.2-meter telescopes with up to 4 extra smaller telescopes. With these so-called unit telescopes and expansions, the VLT makes a singular virtual telescope that gives superior resolution. Assuming we were to set up every one of the individual pieces of the telescope, we would have a telescope with a width of up to 200 meters. With this strategy, scientists are indeed accomplishing phenomenal accuracy with GRAV. Analysts have now expanded the telescope's capacities even further. This heavy instrument uses interferometry to join the light from every one of the telescopes. With GRAV, space experts can notice stars and planets with an accuracy of a couple of millionths of a second of arc. This accuracy is generally identical to being able to see the wings of a butterfly fly on the Moon from Earth. GRAV has now given the main close-up of WG64, and the data is staggering. How do specialists manage a close-up of a giant star 160,000 light-years away? Essentially, they fastidiously investigate each small bit of light to figure out all that is to have some familiarity with that star. The human inclination to investigate is truly special, so we use each technology available to us to unlock every one of the secrets of the universe. Think about it this way: researchers can separate every pixel of such a picture into handfuls or even hundreds of pieces. Exceptional spectrometers and computer programs analyze the visible light traces, and like analysts, they can read extraordinary subtleties from this data. In this manner, our science can easily find out precise insights about a star that is unimaginably far away. Long-term observations of WG64 have shown that the star's light has diminished over the recent years. Now, at last, scientists can figure out insights about the reason why this is so and what associations there are to the star's life. Gravity technology permits analysts to notice the star in real time and to report processes exhaustively. Scientists warned that WG64 is so far advanced that any major change could be a harbinger of its unstable end. Unlike, for instance, Betelgeuse in our own cosmic area, this red giant has already begun to shed its external parts. The star is now self-destructing, and the egg-shaped ring that you can find in the photograph consists of this ejected material. The shape of the case's entrances is a mystery. Researchers, up to this point, have no computer model or simulator that can explain how this surprising shape came to fruition. There are physical forces working around WG64 that we don't yet completely understand. Since the star's light is now diminishing, specialists fear that further close-ups will soon be impossible. The specialists are planning to update the technology in the Atacama Desert explicitly for this reason. Observing a star like this one is of such incredible value to science that no work or cost is spared to examine this star exhaustively until the end. Is it conceivable that WG64 will offer an exceptional chance to watch a cosmic explosion live in the near future? The Large Magellanic Cloud, a grandiose gem, is where WG64 is located. This enormous neighboring universe of the Milky Way is situated in the constellation Dorado, Swordfish. If you gaze toward the night sky, you can see the Large Magellanic Cloud with the eye. It appears as a small cloudy spot in the southern night sky. It was named after the Portuguese voyager, Ferdinand Magellan, who reported the astronomical cloud during his circumnavigation of the world in 1519. At that time, the explorers had no idea they would soon see huge numbers of other suns and even whole universes in the night sky. For them, the stars were points of light overhead and signs for their voyages across the seas. The Large Magellanic Cloud is in our nearby area, a distance of about 160,000 light-years. It is considered a satellite galaxy of the Milky Way. The Magellanic dwarf galaxies are probably gravitationally bound to the Milky Way. Structures can be seen in the interior of the Large Magellanic Cloud that suggest the galaxy is headed toward becoming a spiral galaxy. Right now, however, its shape is still extremely irregular and not as beautiful as that of our Milky Way. The Large Magellanic Cloud also has a width of around 14,000 light-years, which is small compared to our Milky Way's width of about 100,000 light-years. A particularly beautiful feature of the Large Magellanic Cloud is the Tarantula Nebula. This star-forming region is one of the most dynamic in the local group of galaxies. The Tarantula Nebula is so massive that it's visible to the eye as a bright patch. It contains young star clusters like R136, which is home to some of the most massive stars known. R1361 is a blue hypergiant and the most massive star known in the universe, with an estimated mass of around 200 solar masses and a luminosity about 8 million times brighter than the Sun. It is a true behemoth too. However, R1361 is at the beginning of its life. When WG64 detonates in the not-too-distant future, the star will fling its mass out into the universe. From the remnants of its explosion, new stars will be formed in star-forming regions such as the Tarantula Nebula. Of course, it would be a true delight for some scientists to witness this explosion. The Large Magellanic Cloud has already provided the chance to observe such an intriguing display. In 1987, the supernova SN 1987A was observed there. This was the first supernova in hundreds of years visible to the naked eye. For modern scientists, it was the first opportunity to study the explosion of a dying star in detail. Betelgeuse, will we see the explosion soon? While we are discussing supernovae and red giants, one should not be missing Betelgeuse, the most prominent star in the constellation Orion. It will also detonate soon. However, Betelgeuse has not yet begun to shed its outer layers. The final explosion is probably significantly further in the future than that of WG64. In 2019, it was observed that Betelgeuse became significantly dimmer for a while, leading to much speculation. Some researchers thought the end of the star, which is about 550 light-years from us, was imminent. But then the situation quieted down again. As a red supergiant, Betelgeuse has already consumed a large portion of its nuclear fuel. It will eventually deplete its hydrogen supply, leading to a final explosion. The exact timing of this event is hard to predict. We don't have enough experience with dying stars to be able to anticipate the final stage with certainty. Thus, just like with WG64, researchers are monitoring every change on the surface of the star. The precise cause of the brightness change of Betelgeuse in 2019 could be explained by a massive mass ejection. Betelgeuse had surrounded itself with the material released, probably in addition to being wrapped in a thick dust coat, leading the star to lose optical brightness. With this logical explanation, everything became clear. First, Betelgeuse had only like an old, weak man. But researchers caution that the final explosion could happen at any moment. Thanks for watching. Have a nice day.